Today we want to look at reflections. So far we've gone through translations where we slide a figure across the coordinate plane. In reflections we're actually going to do a flip across the coordinate plane. So we want to think flip whenever we see that word reflection. There's a couple of things that can happen when we're reflecting points across a line. And for instance, if we're reflecting across this line here, M, so I'm just going over it to emphasize that. And we have a point that's not on the line, like this point P over here. There's a point that's on the other side of the line that's the same distance away from the line. So here's point P. Let's pretend this is 3 inches, for example. It's supposed to be a 3 there. 3 inches away from my line of reflection, M. Well, that means that there's a point P prime that is 3 inches away on the other side of the line of reflection. So every point not on the line, there's another point that's equidistant from the line going the other direction. This is normally what happens, or it happens a lot when we flip across a line. But the other thing that can happen is we have a point that is right on the line of reflection. Okay, so here's line M again. We're going to reflect across line M. And point P happens to be right on the line of reflection. And when I reflect it, it stays in the same place. P prime is exactly where P is because P was right on the line. So in other words, if I trace this line and I fold it on that line or line of symmetry, these points will be right on the line, right on the fold. Okay, just want you to keep that in mind. These are postulates. These have not been proven. They're just kind of common sense. Okay, so let's look at graphing our reflection across the x-axis. So first of all, I have to remember which one is the x-axis. And the x-axis is right here on the horizontal. Now this one's labeled, so I can actually see where it is. Okay, but I kind of go over that just to remind myself. Okay, so when I look at it, point A is right here, one line above the line of reflection. So I'm going to do the opposite and go one line below. So here's A prime down here. B is 1, 2.5 lines above. So I'm going to go the other way, 1, 2.5 lines below, and there's B prime. C is 1.5 primes above the line, 1.5 lines above this reflection line. So I'm going to go 1.5 times below and put C prime. Now when I connect my points, A prime, B prime, and C prime, I should be able to see that if I fold it on this x-axis right here, this first figure, my pre-image, would end up right there. Okay, and that is reflecting across the x-axis. Okay, very commonly done. Now let's practice flipping across the y-axis. And the y is always this vertical line right here. Okay, and here's my figure, DEFG. Kind of looks like a trapezoid. So maybe it is a trapezoid. When I look at it, D is 1 to the right, so I'm going to keep that same level going and go 1 to the left. And it looks like E is 2 lines to the right, so I'm going to go 2 lines to the left. And G is just a half of a line, half of a way to the line here. So I'm going to go half on the other side. And F looks like it's 2.5 to the right of the line. So I'm going to go 2.5 to the left of the line. There we go. I'm going to go ahead and connect my points and look at this trapezoidal looking figure. Okay, that could be straighter. Here's my pre-image. Here's my image. And I've crossed or flipped across the y-axis. This trapezoid went over here and now it's on the left side. Okay, so when we flip across the y-axis, we're going right to left or left to right. As in the last slide, when we flip across the x-axis, we're going top to bottom or bottom up. Up, down, up. Whereas when we're going across the y-axis, it's right, left, right. Now sometimes we flip across a different line. This line right here, x equals 2, is a line where x is always equal to 2. So find where x equals 2 and draw that line. Okay, I'm drawing it right here. All I did was start at 0, 0, and I went 2 to the right. Oh yeah, x is 2 here, x is 2 here, x is 2 here, x is 2 up here, x is 2 down here, where y keeps changing. This is my line I want to flip across in this example. So I'm going to take m, which is 1 unit to the right, and m prime will be 1 unit to the left. L is 2 units to the left of my line of reflection, because that's the blue line. So I'm going to go 2 units to the right, and that's where my L prime is. N is 1 unit to the right, so N prime is 1 unit to the left, and P is 2 units to the left, so P prime is 2 units to the right of my line of reflection. And now when I connect my points, you can see I flipped across the blue line. I didn't quite clear my first shape, which is of course right here. And when I flipped, it kind of landed on top of the other one. But that's okay. I flipped across x equals 2. So here's my first shape, where this red one is my second shape. Okay, always draw the line so you can remember. This is my reference point. So I just count how many to the one side. Oh, I do the same thing going the other way. Okay, now here's a good example of y equals -3. So y equals -3 is down here. Oops, that's 2. Let me erase that. Got to count better. Okay, let me go back to y equals -3 is 1, 2, 3. Excuse me, it's right down here. This is where y always equals -3. X is all different numbers. So let's see, we're 1 unit above our line of reflection with r, so r prime goes 1 unit below. T is right on our line of reflection, so T prime is right on our line of reflection. S is 4 units up. Yep, 4 units up, so I'm going to count 4 units down. 1, 2, 3, 4. Okay, this is pretty handy because I'm looking at the picture and doing my reflection by counting. That is a terrible line there. Let's see if I can make that straighter. Well, I'm sure that you can, so let's just pretend I didn't do that. You do a straighter line right there, there, and there. And you'll be able to see that this is our pre-image here, and our image where we moved it is now down here, reflecting across our line at y equals 3. Notice how I drew the line, so I'd like you to draw the line when you do that. Now we're going to learn some rules. We're on the next page now. And we have these rules because these are common reflections that we do, and we can always refer to these rules. In fact, we'll be putting them on our note cards in order to prepare for our test. So let's figure this out at first. We're going to do a reflection, a flip across the y-axis. So we need to remember that this is our y-axis, the up and down one. Okay, so I'm going to go over that so I remember that. Now let's put in our pre-image points. These are our pre, and this is our image after we've gone through the machine. So we're going to go -3, +2. 1, 2, 3, 1, 2, there's A. B is at -1, +3, so I go 1 to the left, up 3, there's B. C is at a +2, -1, so I go 1, 2, down 1, and now I have my triangle. I'll see if maybe if I'm really careful, it will look more like a triangle than that last one. Okay, there. So there's my pre-image. Got it. The line I'm flipping across is the red line, remember. So I'm just following what it says here. Let's see, it says A prime. I'll switch colors here. I better go with something like green that stands out. A prime is at 3, positive 2. So I'm going to go 1, 2, 3, 1, 2. There's A prime. B prime is at 1, 3. 1, 1, 2, 3. C prime is at negative 2, negative 1. So I'm going left 2, down 1, and there's my C prime. Okay, let's connect our points here. Maybe I'm getting better. This is my second one. This is the image where the blue one is my pre-image. So now I'm going to look at what actually happened here. I flipped across the y-axis. A went from negative 3, positive 2 to 3, 2. B went from negative 1, positive 3 to 1, 3. And C went from 2, negative 1 to C prime, negative 2, negative 1. So the y's stayed the same. So when I'm looking at the rule, I'm going to keep y the same. But what happened to the x's between x and the prime number? Negative 3 became 3, negative 1 became 1, 2 became negative 2. They went to the opposite. So that's our rule. When we're flipping across the y-axis, we take the opposite of x and keep y the same. And it might be the opposite of what you think, but when y-axis is our line of symmetry, our flipping line, the y doesn't change. X goes to the opposite. So we'll see what happens when we go across the x-axis. So let's flip across the x-axis now. And let's go ahead and do our graph. Negative 5, positive 2 for A. 1, 2, 3, 4, 5, positive 2. A is right here. B is at negative 2, negative 3. 1, 2, 1, 2, 3. There's B. C is at positive 1, positive 1. So 1 to the right, up 1. It's a big triangle. Okay, let me connect these the best that I can. That's a hard one for me there. Okay, so there's our first triangle, and we're reflecting across the x-axis. So the x-axis, if you want to go over that extra dark, is right there. Now, let's see what happens. A prime is at negative 5, negative 2. 1, 2, 3, 4, 5. 1, 2, down. Here's A prime. B prime is at negative 2, positive 3. Negative 2, positive 3. There's B prime. C prime is at positive 1, negative 1. So 1 to the right, down 1. Now I'm going to connect these points to get my image. Okay, so the purple one is 2, and the red one was my pre-image. Now let's look at the pattern. Negative 5 to negative 5, negative 2 to negative 2, 1 to 1. Oh, that tells me x stayed the same. What happened to y? 2 to negative 2, negative 3 to positive 3, 1 to negative 1. Oh, y went to the opposite. So this means that when we flip on the x-axis, x stays the same and y goes to the opposite. Okay, just the reverse of what we did on the slide before this. When we flip on the y-axis, y stays the same and we take the opposite of x. Okay, so that's our second rule that we're going to put on our test. That's why I'm putting a star here. For the rule for reflection across the x-axis, with the line of symmetry being the x-axis, x stays the same, y goes to the opposite. So if it's negative, it becomes positive. If it's positive, it becomes negative, just like in point C. 1 became negative 1, and in A, 2 became negative 2. Okay, one last thing we need to remember here. There's one more rule. And this rule is when we reflect across the y equals x line. Now, the y equals x line may be something you're not familiar with, but it's a line, and let me grab a straight line in my figures here. Let's see, what can I use? Okay, I'm going to use something without arrows. And it goes right through the corners. So I'm carefully putting it through, I think, the corners as I move along. You know me with my eyesight, it's hard for me to see this. And I'm going to go the other way too. and I want to follow how I'm going to reflect across this line. This is called the y equals x line. So I'm going to label that so you remember that, right? Y equals x. So now we're on a diagonal. The reflection becomes a little bit harder. So let's plot these first 3 points. 0, 4. 1, 2, 3, 4. There's 0, 4. Negative 2, 6. 2 to the left, up 6. So we're going to go 2 higher right here. And then positive 3, negative 5 is positive 3 to the right, down 5. Right there. Okay. That looks pretty strange. I'm not sure I counted these correctly. Let me double check that. 0, 4, 1, 2, 3, 4, negative 2, positive 6. So that must be negative 2, and then up 6. And then positive 3, negative 5. So positive 3, negative 5, 1, 2, 3, 4, 5. Okay, it's kind of a strange shape of triangle, but I'll see if I can rough draft there. Very rough. Okay, and to flip it across this line, which would be kind of hard since we're working on the diagonal, we don't really know how far those points are from this line since it's on a diagonal. So I'm going to go ahead and follow what they have up here. Here's my pre-image that I just did, and then here's the image over here where we're moving it after the flip. So A prime is at 4, 0. So I'm going to go 4 to the right and stay there, no up and down because it's 0. B prime is at 6, negative 2, so 2 more, and down 2 is negative 2. And then C prime is at negative 5, positive 3. So negative 5 is 5 to the left, 1, 2, 3, 4, 5, and positive 3 is right there. So let's connect these blue dots, see what that looks like. And there's our flip across the y equals x line. So what I want to remember, really, because this is hard to do just by looking, is what is the rule? What is happening here? I'm going from 0, 4 to 4, 0. On B, negative 2, 6 to 6, negative 2. And on C, I'm going from 3, negative 5 to negative 5, 3. So what would I say is the rule? How is the point changing? That's right. All it's doing is flipping. The y becomes the x, and the x becomes the y. So we want to say our rule is yx. That's what that means. So if we fold on this line of reflection, y equals x, we just need to remember this rule, switch the coordinates, and you'll have the answer. We don't even need the picture.